Today we are going to review for that district test. And remember, virtual students, I have the link out there so you could sign up. I think they give you like a 2-week window to go in and take that test. If you're in person, because I know sometimes I have students that watch this later, we will take it Thursday in class. But virtual students, you need to go out to Canvas and sign up for a time. So I have this review. It should hopefully prepare you and make you successful for the district test. And I think it has 9 questions, and I am going to do my best to go through all 9 questions. Number 1, for which values of x is the function below decreasing? Remember, we call this from here. Remember, this goes up forever. So we say that this is what we call decreasing. And then after you get to this point, which is 1, it starts increasing. So we call this part increasing, this part decreasing. So when I look at this number and I trace it up, that's 1. Remember, you read in terms of domain. So I would say everything to the left of 1. The way you say that would be x is less than 1. So D is my answer. Okay, so you should be able to look at a graph and identify decreasing and increasing intervals, and it's going to be in this notation. This was actually on the starter, but I want to make sure we go over it. It says f of x is shown below. So if it were me, I would probably put f of x, just so I don't forget that this is f of x. And then suppose g of x is a stretch by a factor of 3, followed by a translation down by 2 units. Okay, so translation down by 2 units. Let's see. So I'm going to move it down. I'm going to take this graph and move it down. And usually the vertex is enough. So I'm going to put that down there. If I get the right size, 6 maybe. So I moved it down 2. And then it also wants me to stretch it by a factor of 3. It used to be 1 over 1. So instead of it being 1 over 1, it's going to now be 3 over 1, because we're supposed to stretch it by a factor of 3. So here's my vertex, and I'm going to go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. There's my x-intercept if they ask me. 1, 2, 3 over 1. And continue that pattern. And I usually just fill in the whole graph. And then I'm going to do the same thing on the other side. Up 3 over 1. Up 3 over 1. There's my other x-intercept. Up 3 over 1. Up 3 over 1. Up 3 over 1. And I have my new graph. And that goes forever. And this one goes forever. So notice they asked me to stretch it by a factor of 3. I did. I took it and I stretched it. And then it also asked me to move it down. And again, I moved the vertex down. So now we could try to decide what is true here. And they're asking about f of 0. So let's find f of 0. What is f of 0? What does that mean? That means you go to the 0 and you find the value. So right here would be f of 0. F of 0 is -1. All right. Now they want me to compare that to g of 0. What is g of 0? I take 0, I trace it up, and I get 3. So now we can compare. Obviously, those aren't equal. So I could go ahead and say no to this one. So that one's a no. Now, then this is just asking which one's larger. 3 is larger than -1. So I would pick C. So the answer is C. 3 is less than -1. That is incorrect. I take that back. Actually, I want to get rid of this. F of 0, -1 is less than 3. So the answer should be B. I almost picked the wrong one for some reason. So the answer is B. This number is less than this number. Okay, so another skill is that you could take a function already drawn for you and do what they say and then compare values. Could be less than, greater than, or equal. All right, this one's kind of a word problem, but not really. Let's say you work for a car dealership and your weekly salary is $500 a week. So you get $500 a week no matter what. No matter how many cars you sell, you get that $500 a week. Plus you get 23% commission based off total weekly sales. Create a function f of x showing your total weekly income. Okay, well, let me start off. So I'm going to say f of x, and I get $500 a week plus 23%, which is 0.23, and we'll say x. So x is our total weekly sales. Here's my function. To find 5420, I'm going to plug into that function. So my weekly income of 5420, I would get my $500 plus 0.23 times 5420. So if I plug in this function, it's going to tell me how much money I'm about to get, my weekly salary. So I'm going to go out to Desmos. You're going to have access to Desmos as well. You'll have access to the scientific calculator. And I'm going to type in 500 plus 0.23
Mr. Parks,
times 5420.
it's unmuted and he cannot hear me.
How much did I make? That's okay, 1746.6, so nearly $1,800. As a week, it's okay. And then I'm gonna plug in 1340, so I could just come here and just change that to 1340, and I get 808.2. So if I have $1,340 worth of weekly sales, I get back $808. Really not that great. $30,000, I bet that's a lot of money. So if I have weekly sales of 30,000, but that's going to be a lot. So I'm going to change this to 30,000. $7,400. That's pretty good. And then finally, $100. I can't really expect much. If I only sell $100 worth, I get only an extra 23 bucks. I get my 500 plus my 23 bucks. That's 523. So F of 100 is 523. So to kind of summarize what we did, you work for a car dealership, you get $500 a week. So all of these numbers should be bigger than 500. But you get a little bonus. You sell some stuff, you get 23% commission. And so you sell a lot, you get a lot more money. You sell little, you get a lot little money. So are you able to plug into a function? All right, 4. Let's say you have a deck of 52 cards and you want to arrange the cards so that each row has the same amount of cards. This can be modeled by the function f of x equals 52 divided by x to model the number of cards in each row given x rows. So all I really got from that so far was that this is rows. And f of x is the number of cards in each row. So we're going to look at this, and this should say 4, 13. So is this a possible scenario? So what is 52 divided by 4? 52 divided by 4 is 13. So this is a solution. Okay, so it's going to be B or C. It's on the graph. It is a solution. I guess it's better, I would say it's on the graph. Okay, not necessarily a solution. So that's on the graph. 13, 52 divided by 13 is 4. So that's on the graph. 52 divided by 5. Let's see what that is. I can't do that in my head. 10.4. So that's on the graph. What's 52 divided by negative 13? Negative 4. So that's on the graph. 52 divided by 1 is 52. That's on the graph. 52 divided by 10, that's not 6. So this one's not even on the graph. So for 6, I would say 6 is A. Okay. So all the rest of these are on the graph. So it's either B or C. This one's not on the graph because 52 divided by 10 is not 6. So now the question is this a solution to the situation? Can you have 4 rows with 13 cards each? And that would be yes. So not only is it on the graph, but it's a solution. So for this, I'd say C. What if you did 13 rows with 4 cards each? So it did the opposite. That is also on the graph and a solution. You could do that. 52 divided by 5 is 10.4. You can't really have a partial card. So even though 10.4 is on the graph, it's not a solution. So I'd say B. And this is saying you can have negative cards. So even though it's on the graph, it's still not a solution. And if you wanted to have one row with 52 cards in it, that's perfectly fine. So this is on the graph and is a solution. So that's C. Okay. You will see a problem very similar to this. Determine whether each is always true, sometimes true, or never true. So if you have f of x plus k, remember we said plus k means it goes up k units. So that's always true. This one's saying plus k will always is the graph of the function shifted up absolute value of k units. And that is not necessarily always true because this could be a -2 and you don't need to take the absolute value. So this one I would say sometimes true. The graph of f of x minus k is the graph of the function shifted down k units. That's always true. The graph of f of x minus k is the graph of the function shifted down, make it positive units. That would be minus moves it down. That would always move it up. So that'd be never true. Okay. In other words, plus k moves it up, negative k moves it down. You don't have to look at the absolute value of it. This part, you're going to see a few questions just like this. And I know kids are still struggling with this. But when it says f of -6, All you got to do is go down to the x of -6 and then trace it down to the graph. And you'll see that f of -6 is -6. And what's f of 0? So you go to 0, you trace it down, and you get -3. So that's all you would do is you just plug it in. Like, so if they ask for f of 6, you'd say 0. F of 8, you'd say 1. F of 10, you'd say 2. Now these are saying what value makes the y value of 1. So instead of tracing this, you'd go up to 1, trace that over, trace it down, and you get 8. So if I plug in 8, I get back 1. So this should be 8. And for what value of x do I get a y value of -7? Go down here to -7, trace it over. That would be -8. So if I plug in -8, I get back -7. A function f of x has undergone a transformation. Explain the transformation from the parent f of x to g of x. This should be fresh in your mind. Remember, plus, or that's a minus. -3 moves it to the left 3. +4 moves it up 4. So I would say right 3. I may have just said left, but it's right 3. I'm up 4. So that's all that happens. It gets moved 3 to the right and up 4. This one, the negative reflects it over the x-axis, and the -1 moves it down. So I'd say reflection over the x-axis, and we're going to move it down 1 unit. Here, remember the 4, any number bigger than 1 causes a stretch. So it's going to be stretched by a factor of 4, and then the 3 moves it 3 up. So stretched by a factor of 4, moved up 3 units. 1/3, any number between 0 and 1, not including 0 or 1, does what's called a compression. So this is going to be compressed, and this is going to move it to the left. So compressed by a factor of 1/3, moved up 4 units. Oh, not up, I almost made a mistake. Inside the parentheses is left and right. So that should say move to the, and it's the opposite of what you think, move to the left 4 units. I didn't make that mistake here. Nope, to the right 3, up 4, reflected, down 1, stretched, up 3, compressed, left 4. Okay. All right, select all of the following that represents a translation on the left on the coordinate plane. Oh, I can't read. Select all of the following that represents a translation to the left. So does this cause it to go to the left? No, it causes it to go up. Does B cause it to go to the left? No, it causes it to go down. Does C cause it to go left? No, this one's right. I'll even put that. That does up. This one goes down. This one goes to the right. This one goes to the left. Because it's inside the parentheses, it does the opposite of what you would think. +4 makes it go up. -3 makes it go down. Because it's on the outside. -1 makes it go to the right. And +2 makes it go to the left. So this was like multi-answer. So which one makes it go to the left? Not that one, not that one, not that one, this one. And this one. So select all of the following. I would pick D and H. All right, number 9 is actually pretty easy, but unless you watch this video, I'm going to guess you're going to miss this. So we have f of x is 2x plus 5. So if they want me to find -2 times f of x, what that really means is just take -2 times 2x and times 5. So what I get back, if you take -2 times 2x, you get -4x. And if you take -2 times 5, you get -10. And that's it. Okay, that's how you find -2 of f of x. You just multiply everything that's in the f function by -2. I'm going to do something a little different today, just to make the video uploading a little bit better. So normally I have to like clip off the beginning and the end. I'm going to start just ending the session. That way the video could go ahead and start loading. So I'm going to go ahead and hit end, but then I'm going to sign right back on. So if you need any help, you could go ahead and sign off. And then if you want help, you can sign back on. But I'm going to go ahead and end the session. That way the video will start loading. And then if you need help, just log back on. All right. Nice seeing you. Talk to you later. Bye.